Sometimes I intentionally put the wrong answer in there. And if you get that number, then I want to know how you got it. It's a made-up number, right? I'll put in 17 pi and move some decimal place around, and see if somebody takes something like no one's ever done before, which is nice. Never happened. And then other times I've made mistakes on the quiz. And this time Vince made the same mistake I made, and that's how I found it. I was like, oh, that's what I did. How I got 0.939. It's not 0.939, it's 0.999. 0.939 is if you used, so room temperature should be 290 Kelvin. And if you fat finger 75, which was in the question, to 70, you get 0.939. So you still got full credit because I made the same mistake. I caught an error on the quiz.
Which is gracias.
Which one?
Today's going to be a spice-heavy day. Asterisk. While I was grading quizzes, my laptop blue screened twice. Yay, IT. So, we will see how much spice we can get done, because this isn't one of those things where I can just willy-nilly grab a different computer and use the one that's in the room, because I have to have spice on it, and you can't install anything on these computers.
I mean, to be fair, you know there was a computer there.
Yeah, there's a computer in every room. I mean, they're garbage, but they're there.
Vincent.
Will someone put the light closest to the trash can back there so we get the...
I think I passed it.
Oh my god. When I look at that question, I went to page after page and I realized I don't understand any of them. And I just sit there and looking at the question and I
Just
don't
don't listen to the
understand
track.
any of those. But
He
constantly,
definitely tells the curve on us. He didn't trick us, but I definitely
it was
feel
so
like he's
complicated.
I mean, he gave us some practice in the midterm that was 20 questions long.
I know. He made a trick exactly for the parallel, the words parallel and series. Oh my gosh.
Okay, answer keys. So, the first problem's on the first two lines. We just did KTB, right? K, temperature, bandwidth, I gave it to you. You should have gotten some number of watts. And if you 10 log 10 that over 1 milliwatt, so you got the right answer. One of you put 133 in here instead of 113, and I knocked off a couple points and just said, I hope that's a typo. Because I don't know how you got to 133. Unless you did the conversion wrong, but even still, it's a small thing to do. So that's how you got to negative 113. This is the second problem, should be 0.99999. If you put 1, it's fine. And if you fat finger this into a 0 here, you get 0.9.
Didn't check for the second time, I just submitted.
So that's why everybody said, when it shows you 939, that's why people were saying 939, because I screwed up.
I screwed up.
Whoops, happens. It's not the first time. Most of the errors I've gotten corrected out of the quizzes. I think this one I forgot about. This is by far the most casual class I have, and it's a little fast and loose compared to, let's say, the last term or other classes, so they're not quite as structured. And that boils down to the quizzes. Let's open up the quiz itself, though, and hope for no blue screens. How were weekends?
I got 10. I told you, I was just looking back and forth, and I was also
Yeah, we're gonna get
by
into
the
these questions.
stack.
The image is always what gets people.
I don't know, when I submitted it was 10 and I just said, fuck it. It doesn't matter. You know? I was just like looking the back and forth and I just didn't pay attention. It's fine. How many percentages is a quiz? 10? Okay, fuck it.
All the grades aren't completely done. I didn't realize that I made an error, so some of you guys have full credit for things, or some of you guys have points marked off for things that will ultimately
Probably
write
the
after all.
20 is mine.
Particularly on the last problem, because I changed some numbers. So there's 113.99, and that's what you guys should have got, unless you make the same mistake I did. Everybody got this except for one person put 2.1 instead of, it should be 2100 kilohertz. Remember, you're just adding those two numbers together. sorry, you're adding that up. So you were just a couple orders of magnitude off. Yeah. It wasn't you, you got it right.
For that, 0.93.
Mhm.
So if the room temperature is gonna be like T equals 290
Yes.
degree Kelvin.
Yes.
Then it's gonna be a different answer compared to when we have 95 degree Kelvin. I remember I checked both of them.
If you, room temperature scientifically is agreed upon. I don't know who decided this. It should be 290 K. But you didn't get it wrong. I got it wrong on the answer key. Because when I did it, I solved for what is it when this is 70 K. 70 K over 290 K instead of 75 over 290 K. And that's why it was different.
So either one is okay, 295 or
290.
290 is correct?
290 is the correct room temperature value for all calculations involving noise temperature. Or generally anything. 290 K is room temperature. It's sort of agreed upon.
295, we saw fragments with 295, right?
On the slides, in the lecture slides, and that's why I made a joke about my wife being from Phoenix, Arizona.
It's like
There's a note in the slide below.
it's like some textbooks, it's like plus 10 Kelvin.
The difference is so minimal, it's very small. If you did 75 over 295, the difference is very small.
It gives 1, 2.
Yeah. Yeah. It's almost indistinguishable answer. If you do 70 over 295, it's off, no more noticeably, which is what I did on the answer key.
If it's tiny,
Alrighty, this one, everybody almost got this one right. If the image of a signal, let's draw the lines again here. That pen's gonna be dead, it's gonna matter. That's frequency. And the image of a signal is at, where the hell is it? Image of a signal, the signal is at 970 and the image is at 1880. Is image good or bad?
I guess bad.
Bad. Bad. Signal that we want is way over here at 970 kilohertz. Just with those two pieces of information, you can tell me what the LO is. Where is the LO geometrically related to these two lines?
In between,
Where in between?
the center.
Precisely in between,
Yeah.
right? Exactly in the middle.
It's exactly split.
So this is my LO. I actually don't care what frequency it is. And this gap is IF. And another IF away is the image. The LO is the mirror for the image, right? So yes, some of you put 910, and that's the distance from here to here, but that's not the IF.
Got it.
Hmm?
So, is that in log scaling for frequency?
No, that's just subtraction.
So if we saw the log scale, they would not be spliced, right?
Oh, sorry. If they say that they're exactly in the middle, this is not logarithmic.
Yeah.
Yeah, the log scale, if you look at like in LT-Spice, the log scale looks like, let's say you have 100, and then you have 110, 120, 130, 40, 50, 60, 70, 80, 90, sorry, 200, 300, 4, 5, 6, 7, 8, 9, and then you have 1,000 as a decade, and they split, they're not linear across this gap here. This is not that. Yeah.
Because it's not geometric.
Yes. Well, it's just easier to view big, wide things in this format.
Right. And it would be centered if it was geometric.
Yeah, if you did geometric mean to be set, but it was literally just fractional. Double balance mixer, there's just a, do you know what double balance mixer means? Double balance means that both of the inputs are suppressed. Single balance means only one of them. That one was true. That was a 50-50 one. All right, this one, a few of you have gotten partial credit for this that don't deserve it, and it's because I changed my IF frequency from last year. And then bonus points for the, I think, 2 of you that pointed out that's still not a good design with this example. So, I'll explain. So our example station is at 100.3 megahertz, and the FM band goes all the way down to 88 and all the way up to 108 megahertz. So there's FM. And here's my station. So I can draw one. I need to build an LO in blue here. Let's see a high side or low side injected. So I'm going to draw both.
The high side is the
So
lowest
here's LO high. Here's LO low, which is kind of funny to write. Let's draw these better to scale so that they make sense. It's more like this. And this. So, some of you noted that, actually most of you noted, that if this is one IF jump away, then the image has to be yet another IF jump away. And here's my high side image if I had a high side injected LO. And conversely, here and here, 0 point somewhere else. And this would be image on the low side. And some of you would say, yeah, that's no problem for Z100. And you'd be right, you did. Some of you have points wrong. Last year, my IF was a smaller, so it did fit in between in the middle. That's why I initially marked you wrong. I forgot that I changed it. But Parveen stuck out, and what's wrong with this if you aren't at Z100? Anybody but Parveen? I know she knows the answer because she put it in her quiz. Yeah.
Because if you're, because your image range is between like 114 and 87 megahertz.
So if I have a high side injected, let's use the high side example. The high side injected LO, and my IF is 6.8, then this high side injection frequency is at,
107.1.
thank you, 107.1, and the image is at 6.8 higher than that, which was like 113.9.
Yeah.
Sure, that's not an FM band, I don't care. Or maybe I do, it's the same issue you have to deal with outside. But what if I tune to a station, what if instead of tuning to Z100, what if I tune to 92.3 KGOM? Now I've moved this 8 megahertz roughly, 8 megahertz down, so all of these other things have to move 8 megahertz down. So now my image is in the FM band. You can just yell.
Oh, okay. So for the 10, but if the normal IF is 10.7, wouldn't that happen anyways?
No,
Why?
mathematically it doesn't work out that way.
But if it's,
Remember, your image is always 2 IFs away,
because it's 20 higher, whatever.
and it's 21.4 degrees. So even if you're tuned to 88, if you go 21.4, you're already outside. So that's why they pick those frequencies, so you can tune to any station. For 100.3, this example, I just picked radio stations that I happen to know in the area. 100.3 is pretty much in the middle of this, right? It's almost exactly in the middle of it. So that's why in this example it worked out so cleanly. But if I picked a different station, then you would go, oh, you know, did you do it from both sides? That's how other years had it where they had to do it from each side. And some people said, oh yeah, it's fine, the image is way over here. And I'm like, but what about if you had high side injected, then you've got a problem.
So for the image question, the previous one,
Yeah.
isn't it if you reduce RF, you also minimize the image?
So that's why.
No.
I was gonna ask the same
Why not?
Your image is,
You're saying minimize only the image?
your image isn't something that's created. Your image is something that's already there in the radio.
Isn't it a copy of RF?
No, not at all. Very good question. All right, let's talk about image. I'm gonna go back to AM example. So let's say AM lives here. Anybody memorize the AM band start and stops yet?
540 to 1700.
Nice.
That's not memorized, it's have it written
That's fine. So that's my whole AM band, right? The whole thing. Every station, all like 117 or something, remember in there. Let's just pick one. I'll use blue. Our station we want is, let's say it's, I don't know, here, it's 1080. I use that for a lot of examples, I don't know why. And our IF frequency is fixed. That's 1080, this is about, I'll try to do this to scale. This is probably something like 455K, and that is my IF. If I'm being really pedantic about it, I'll say that is my IF difference frequency. And the IF sum is where?
Are you high side or low side?
down.
So if I give you these two bits of information, where is the sum frequency out of it for this mixer? You have everything you need. It's not all the numbers aren't on the board though. What do you need to know first?
Well, your LO is going to be the 10.
You need to know the LO,
Plus.
yeah. And we're gonna say it's high side injected just to make life easier.
Mhm.
So our LO is gonna be somewhere here, and realistically that's gonna be shorter, right? And so will that. So my LO lives here. So where is my sum frequency? It's the addition of these two, and this is gonna be at 1535, okay? Okay. So theoretically, way up here, I'm gonna have 15. Okay. This is my IF sum. We filter this out. It gets easily filtered out. It's way. My image though, let's get a color. My image in pink, is pink? Yeah, it looks different. My image is exactly one IF away on the other side of my, and I'm going to represent it as one frequency because we're just drawing everything in like perfect Dirac delta functions just for the sake of simplicity. My image is here. And it's either there or it isn't. And it has nothing to do with what you've done. It's a matter of where you are. Are you in an area where someone is broadcasting at this frequency? And it's 1535 plus 455, which is what number? First with a 2. 0, 1, 3, no. 0, 9. Don't make me do math. Someone get a calculator.
I have.
No, can't be that.
Do you want it?
Huh? Did you finally got one? You guys are killing me. I can't add either, but 15,
1990.
35 plus
I
455.
was stupid. Why I didn't put the plus?
1990. Told you it was 1990. Which is outside 1700. Great. Fine. So, is somebody broadcasting at 1990 kilohertz for your station? If they are, then you have a problem when you tune to this station with this LO at this IF. If nobody's broadcasting, you'll never know. You'll never know if there's a problem or not. Something has to be happening here, receiving it off your antenna. This comes in, it could be some maritime radio, it could be some dumbass with a charging bowl in Las Vegas, it could be a whole bunch of other stuff. 1900K is really close to the switching frequency on a DC switching power supply, for example. Right? That's about roughly 2 megahertz, and this is roughly 2 megahertz. So a lot of switchers like to switch at 2 megahertz. It's really common. I don't know why they picked that frequency, but and it's not like it's not like it switches on the nose at 2. It's a big gnarly mess. So it's going to make a big wad. Your image noise might look like this. Your image might be about 2 megahertz, right? So now I care about, well, there's a whole bunch of crap I have to avoid. Maybe I need to filter that out before it gets in my system. But no, there's nothing you can do about the amplitudes of your LO or preamp of your RF signal. It has nothing to do with what's already present in the environment it's broadcasting in that space. Does that answer your question? Does that answer everybody else's question they had? I can keep talking about it. Okay. We good with the quiz?
Mm-hmm. It always good.
If your last name is towards the beginning of the alphabet, you more than likely have more issues with your grade being wrong. I'll fix it when I go home tonight. I didn't catch the problem on the end with the AF band until later. So if you got partial credit on the last question, chances are you didn't. I just need to go ahead and fix it. And in this first one, it was just some people just got rounding errors and stuff. So no big deal. All right. What I want to do today is not open Inspectar, which is a really cool tool, but I don't have the hardware for it to show you. We have an augmented reality overlay. You can put a circuit board under, and you can see all the traces through the board if you feed it the board file.
Have you watched the video at all? Did
If
you?
you've got,
Did you watch the video?
so if I have this noise bump here, there's a bunch of crap going on, and I want to tune 1080 with an LO of 1535, and I have this super nice, let's find another color here. I have a million colors now.
Why does it not? Why is it not
Purple.
switched?
I have this super nice filter here, right? And it's plus and minus 7.5 kilohertz, because it is. So I've got 15 kilohertz of bandwidth there. What's going to happen is that a slice exactly in that tuning range, that slice is going to get copied over and also going to live in here. And if it's bigger than my signal, I'll never be able, I can't get my signal out of it. The rest of the noise gets sliced up. This is my 15K here. It's the same 15K. But this chunk gets copied. Actually, all of it gets copied. The entire lump gets copied, but only the parts in the filter here has image in it. And if the image is louder, or if the noise is louder than the audio, or if it's just messy.
That's because the image is mixed with the LO.
Yeah, everything gets mixed. When you put, maybe this is a better point to make. When I run a,
So, won't you have a bandpass for your RF though in the 547 range?
it's a good idea. What's IFF stand for? Yep. So this is my sum and difference. And what I want out of this is difference only, right? So that's what the filter does. But when on my RF station, this is just one frequency. If we can help it, our LO is exactly one frequency, but we can adjust what frequency that is, right? But this is going to receive literally everything it can. So this is an AM radio antenna. It's going to pick up the entire AM band. It actually picks up every single station in your RF. You're not tuning to one precise one. You're tuning an LO so that the output product releases a difference frequency that filters every other station out. But at your IF here, before it's filtered, you literally still have every other station. And you have every station copied twice because you have it at sum and difference. And it's a mess. If you look at your IF output, actually we'll do it here in a second. If you look at your IF output in SPICE, I'll run my giant simulation here. You'll see that everything that's copied out now. In SPICE, I only have it receiving one channel because I didn't want to make a huge mess. But if you do this, every station comes in. You're only down converting. I just want to take the copy and slice, and I want one station to land square in this filter, and then that's what I can process on.
So is image rejecting just a bandpass before the mixer?
Yes. So if you know that you're receiving AM, maybe you build a low pass filter and it cuts off at, I don't know, like 2.2 megahertz, right? Or maybe it's even 1.8 megahertz or so, right? So I want to filter and I want to just chop all that off. Hey, that'll work. And now it doesn't get in there. The whole AM band does. Or maybe I build it as a bandpass, right? And I only want to.
You still have the low.
You can do that too, and just say I only want the AM band in this. You could do that. We won't have to in our projects because our RF input will just be a signal generator, which doesn't have spurious transmissions on it, obviously. Yeah.
Okay, so if the image signal is also the AM band, it also influences the signal we want.
Depends on anybody broadcasting there or not. So if your image is inside the band, that's a bigger problem because chances are, if it's inside the band, chances are there's eventually going to be a signal there. Maybe not today, maybe not when you're here in Portland. If you take your radio somewhere else, maybe there's a channel broadcasting there. Maybe somebody's doing something that's making noise in that area. But if it's outside the band, the FCC is supposed to keep those transmissions down, or they say that the stations that are the image band for AM and FM are usually reserved for like maritime stuff. Like if you're out in boats in the middle of the ocean and there's no AM and FM radio in the middle of the ocean. They don't have broadcast radio out in the middle of the ocean. So it's like, okay, well you can use that up here and then you can use this other stuff over here. And since those two applications of radio don't typically get used in the same space, cool.
So it's better to use the filter of the eye.
One of the earliest things you'll learn in careers in analog is you'll just filter early and often. Amplify, filter, amplify. Just, hey, we hit it with the hill filter, you know, let's hit it with another filter. Hey, the insertion loss sucks. Just give it a boost with the amplifier and filter it again. It's just filter. It's because you're trying to scrub out everything and keep it clean. And if you want to throw money at the problem, then you can do that all day long. But all right, I am going to open this, and then I need to take a break really quick. Yeah.
For this one, you came up with an example of AM. How about FM? If it was FM, then...
Same concepts.
We never saw that.
What never? Yes, yes. Oh, yeah, there's an image for FM.
I thought, because in your slides it says that image AM is.
For yes, that's a detail on the slides. So for AM, I've got. Are you losing colors here? So I've got AM, the AM band. And right, these are fixed IFs, so it's a fixed IF for AM. And in red for bad, the image band overlaps this, right? And this area is of major concern. And that's why you'll notice there's actually not that many stations past that point, past like 1430 or somewhere in that ballpark. There's not that many stations, and if they are, they're usually really weak broadcasting stations, like KPSU is in the basement of Smith. But if you go, like if you're here, I don't think we can pick it up. It broadcasts a tiny little range, so it doesn't interfere with everybody else's stuff. I don't know if we can pick up KPSU here. And so really small, little dinky AM stations, not like your sports radio or even your weirdo right-wingers are out there. FM, similar, has a fixed IF. Obviously the frequency is different. I'm not going to draw this to scale. And the entire FM band is here, but because of the way they did the IF, the image actually has a gap. So this is FM image band. The math still works out the same. It just doesn't happen to overlap. And this is a better design. That's why we can use the entire FM band for whatever stations we want. In fact, one of the most popular stations, I think, in Portland is at 107.5 megahertz, which is almost at the end. It goes to 108. And so we have 107.5 way over here, and we don't worry about this image band because it's too far away. For AM, it happens to overlap because it's a much older system. You didn't take that into consideration, I guess. Okay, so here is the entire project with some caveats. This is not the same file as you have in the Spice deck that I gave you for a couple reasons. One is a major one. I have a differential to single-ended converter in that Spice file, and it kind of works, not very well. I'm going to replace it. I'm going to work on that, and I'll give you guys that file. If you guys want to work on it too, bonus points. For real, bonus points. I tried to do it with one op amp, but I think the better designs are going to use two. So since the 5532 has two op amps in it, that's convenient for me. But we're going to step through this thing, and we're going to start at the RF. So here is how you make, without having to learn all the weird fancy stuff, this is how you make FM or AM modulation. So you have a carrier signal. In this case, I have channel 1100. I made that channel up. It's Spice. I can do what I want. I don't know if that station really exists or not, and I don't care. It has an amplitude that I set as a variable, and this has a DC offset and an amplitude that I set as a variable, and that's just kind of how Spice has to do it. And then I have some data frequency. My data is a 1 kilohertz tone that I'm going to play. I set this to 250 millivolts, and I have my carrier and my data. And if you make a B, remember B is a behavioral voltage source, so you can multiply, add, copy, all that kind of stuff. So this voltage is multiplying these two sine waves, which is exactly what device? The mixer. I just didn't want to make a whole other Gilbert cell just to do this. I could have. This is my mixer. It's just multiplying them. I get the exact same output. And if I run this, which I have to do anyway, it takes quite a bit to run. I sped it up a little bit, but it still takes some time. Okay. And top vertically. And if we look at my RF input, amplitude modulation, exactly like you'd expect, you've got 100% depth. It goes all the way down to 1 pixel at 0 millivolts. So that's my input signal. So that's what I want. That's what's going to come from my signal generator. That's what AM looks like in the time domain. If it's perfect, it's not going to be perfect. Even from this looks more perfect than even the signal generator can put out. Because remember, the signal generator is just a fancy analog or digital to analog converter, and so it's taking all these little steps, so it has noise. So it's not going to be perfect anyway. So to that, I have our Gilbert cell, and that's my RF input to my Gilbert cell. Notice I put it on the bottom, and if I put it on the top, if I had swapped these inputs, it would have made what difference? No. Exactly. Doesn't really matter. And then I have an LO signal. And my LO, if we follow this back, I've got a big filter in there. I've got an amplifier with some filtering. And here is my signal. I'm going to add a new pane here. Put it above. And let's take the output of this signal. And just looking at this, I'm like, okay, I see two things. I see that this is mostly amplitude stable. The tops and the bottoms are roughly flat. And then if I view my FFT, I can make some conversations about how strong this is and how many harmonics there are and all that kind of stuff. And it's roughly centered right in the middle of my band because I need to be between 995 and 2155, or more generally 1 and 2 megahertz. And this is pretty much right in the middle of that. So that looks good. So why did I amplify and filter it then?
You were mentioning there's a weaker signal, so if you need to amplify it.
This one does happen to be a pretty weak signal. So in Spice goes, oh, hey, I can drive whatever, because I'm not real. I'm not a real boy. This is just a Pinocchio signal, right? It's lying to you. And when I built this in real life, it collapsed as soon as I tried to drive a mixer. So what do you do when something can't be driven? You give it a really high input impedance amplifier and a 600 ohm output, which is a 5532 in this case. And if you're going to amplify it with an op amp, you might as well do some basic low-pass filtering. So I chopped it off at about 2 megahertz. And then you go, oh, Nick, doesn't that cut off 2155? And I say, yeah, but who cares? Not that much. I mean, yes, some. But when do we need to tune up to 2155? When we're tuning to 1700, right? And how many stations are at 1700? How many stations live here? Not that many. So as long as I can hit the bottom half of the AM band, I'm going to pick up most AM stations. Your LO should run all the way to end, but it doesn't have to be full amplitude. In fact, if yours doesn't run end-to-end all the way, and I don't care. I don't want you guys to stress out about it, but I can get you 1900, but not 2155. Just stop stressing. Yeah.
I'm sure you brought this up before, but what is the idea of the 7th order low-pass filter at the end of the
I was trying to spook people into building it, and the Sams of the world who just want to copy my projects. And so if you want to copy it exactly, then you can build my 7th order filter. Or you can design your own filter, but it's less complicated. Yeah. So remember, this isn't intended to be a kit class, and what have I given you here? The entire schematic. This isn't intended to be the answer key, but if you want to treat it like it, then you have more work to do, because you have to build a whole lot more.
We're gonna do this now.
So if we look at this, and if I look at the output of this stage, and I view it, put them both on there, and now we see a little bit more noise because we've amplified it on the outside, but I should have a little more amplitude here, and I do a tiny bit. Couple dozen. Is it very good? No, I don't care. I'm not trying to build this for you. Look at these resistor values. Do you think that those are going to give you any gain? They're not. They're unity. I'm using it as a buffer. Just a buffer. It's unity gain with some filtering. So not a ton of gain. It happened to have a little somehow. I don't care. So there's my output from that. And then I go, well, do I want to filter that? And that's my actual LO output. And if I look at my actual LO output and view it, and let's just look at LO for a second. Then I have this nice pretty spike. And you go, oh, that's awesome, I'm going to build that.
Yeah.
Do you think that this is the greatest method, taking an FFT in Spice is the greatest way you could do this? And just looking at this image?
No.
Good,
No.
why? Which is the hard
Because
question.
this is the Pinocchio circuit.
It's a little bit of Pinocchio, but what's one thing you probably should do just maybe causally?
Just look at the
Why don't we zoom in on this a little? Right?
Zoom in.
Like, yeah, that's a nice pretty spike, but I mean, we're looking at 1, 2, 3, 4, 5, and some change decades. And if we start zooming in on this, we start seeing, oops,
Oh, so ugly.
I mean, it's not that it's awful,
I was.
that's passable, but look at all the sidebands. They are there. And yeah, you can make some, oh, that's, roughly at negative, 4 dB, and this might be at negative 14, and okay, yeah. So, let's measure that frequency and see what peak it is. Okay, I did this. Let's call it 1554. Actually, I'm going to just copy this. And pop that down. And call it Meg. There's a tool built in to Spice. And I don't know who teaches signals and systems, and I bet they don't like this. But you can do all this stuff in Spice, and you can find out the total harmonic, total harmonic distortion of a signal, and Spice will just tell you what it is. Who knows how to calculate total harmonic distortion? Okay.
It's a nasty looking equation.
It is not really that hard. It's tedious, but it's not hard. And I don't remember it all, and it doesn't matter, because
Isn't it
Spice is good. Basically, what you do is you have your signal.
square root of?
So I've got a noise floor. Right, noise bad, so it's red. I've got a fundamental signal. Let's say it's 10K, for the sake of argument. And let's say I just have like a generally messy signal, so I'm going to have some power at every integer multiple of 10K, right? So I'm gonna have 20K, 30K, 40, 50, 60, whatever. And I have that harmonic distortion. And we see that when we look at that T of LO. We see that. And now keep in mind this is at 1.2, so at 3 I've got a spike, and I have these spikes. They're not in linear order because this isn't linear at the bottom, right? This is a logarithm. But a lot of these spikes up here are harmonic distortion. I'm going to run this one up. So the way you take harmonic distortion, you say, hey, what's the voltage level? Not the power level. Well, ultimately you want the power. You want the power of this harmonic, this harmonic, this harmonic, this harmonic, this harmonic, this harmonic. You add them all up. And then you divide it and you take a log of it. And there's a percentage, there's a whole formula. I don't want you to remember formulas. I want you to look stuff up. Total harmonic distortions on Wikipedia, piece of cake. But what I'm going to show you is if I do a .4, like Fourier, not the number, of the frequency that I want as my reference, and this is the one that I pulled from itself. It says, hey, this is my highest frequency, was 1.5542 blah, 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 blah megahertz. I want to take the first 10 harmonics. By default, it'll do 9. You can put whatever number you want in there. The number of periods, if you make it -1, I have these notes, by the way, here. Yes, I'll share this. If I have this number as a -1, it will evaluate the entire trace. If you leave it blank, it'll still run, but it only does 1 period. And then you tell it what signal you want to compare against, 1.5542442 megahertz. And it'll give you the total harmonic distortion when I hit Control L. And I can scroll down, and hey, there it is. And I've got a total harmonic distortion of about 50%. So half the signal's harmonics. It's not great, right? This is a good way to validate what you've built. If you want to, let's build a voltage source and a ground, and put that ground off center without care, because I can do this, right? And I call this Maddie, because there's no harmonic distortion there. And I set this to sine wave with the frequency of, paste that, type meg again, and give it an amplitude 1, who cares? And then if I change, actually I'll just copy it. Actually I'll just add to it, that's even better. Because you can keep typing sources, so you can go V, Maddie. And I'll run it again. And you can see on the bottom of the screen it's running 20%, 22, 25, 27, takes a little time. And you have to let the waveform complete drawing before you can type Control L to get your error plug out. Alright, so now I hit Control L, and it's going to give me the total harmonic distortion for LO, because that came first. And now it's at 5%, go figure. And where is Maddie? Maddie! Thanks. I don't know why I didn't. Did I type it right? What?
Wait, so you're just taking a THD of a much nicer?
I'm making a perfect one, and it should be a total harmonic distortion of virtually 0. It actually won't be 0 because it's still spice and it has
Yeah.
its own stepping that it does. It's not truthful either. Harmonic distortion, 0.5%. Right. So.
It's funny.
And then I'll just F9 back out, so I keep my circuit the way it is. Okay, so that's how we can say, well, I have a lot of harmonics and I can look at every single one and tell you the DVC, and yes, that's a good way to determine like how much of your signal is good or bad or whatever, and it's not that it doesn't work. It's just another tool in your arsenal. So this total harmonic distortion, if we just look at this again, remember this one had a harmonic distortion that was quite high. Let me run this again. Let me just make sure. I think that might have been an error. I gave it one frequency, so I'm wondering if maybe this is too precise. Because this one actually isn't that bad of an LO, especially after I filtered it this hard. Even though it's just a low pass filter.
Seems kind of high.
Half percent is fantastic.
Well,
A triangle wave has, by definition, 12%, 12.1%.
because the amplifiers we built in this one's class, she was like, your harmonic distortion should be at 2%.
If you're building a pure sine wave, yeah. And ideally, we're making a pure sine wave. So that looks good, and if I control L on this, there we go, 6%. I don't know why I forked up the first time. 6% ain't bad. It's not perfect, it's far from perfect. Filter it more if you're really picky about it, but 6% ain't bad, it'll work. And if we look at this, if you just want to see what it looks like in time domain, which is literally the worst way you can evaluate it, and it looks like that. It's not bad. It's a little swirly, and you know.
It's choppy.
Well, some of this choppiness is because I ran it for so long, so you're seeing the signal doesn't actually look like this. This is a step that it's taking because I've been running it for so long. But generally, that looks all right. I'm okay with that. Okay, so I've got an LO and I've got an RF coming in. What do I get coming out? Let's add attain above and zoom everything fit. I'm going to get an IF minus, I'm going to get an IF plus, right? And you guys are used to seeing something like this. Is this the sum or the difference?
There's a difference. Wait,
Who thinks it's the sum? Who thinks it's the difference? Who thinks I'm talking with you on it's both?
It's both.
Both? Both. It's both the sum and the difference. So even in the lab when you're doing a mixer, you're seeing both the sum and the difference when you're looking at the correct answer. And we can validate that
oh wait, this.
if we FFT this, and this actually looks really good. So for the sake of argument, I'm going to view the FFT of RF, IF plus, and IF minus. And hopefully this doesn't make a huge mess. And it makes kind of a mess. All right, I'm going to turn these off. Delete that. Let's look at the RF trace coming in first so you can see something. So we set a 1080 channel, and that's our biggest peak here. But if we zoom in on this, look at that.
Oh.
There's my 1 kilohertz peaks. Now this is because Spice is making it, right? If you zoom in too far, then you see it kind of look jagged like this. But those spikes are so small to see, you really have to zoom in quite a bit to see them. So there's my AM, right? There's my carrier frequency, and then I'm a sum and a difference off of my data that I put on it. The reason the sum and the difference are so close is because the data, the bandwidth in this case, is so small. If it was IF away, it would be way, way, way far away. But in this case, it lives really, really, really close because the data is constrained, in AM's case, to 5 kilohertz. This one happens to be a 1 kilohertz tone. Okay. So, if I look at the FFT of, I'm just going to do one of these because it actually doesn't matter. And so now 455 is right here. And if I zoom in on that, hey look, there's my same 2 spikes and some ripples that go down along the way. Now these are like at 40 dB down, so these effectively are not there. And in fact, if you right click on the vertical axis here and you go linear, it looks a lot more, this is what it looks like in volts, in frequency over volts. So you have the carrier and then roughly halfway down your tones, and then you got some ripples down there that we don't necessarily want, but you have to do them. And you put this in logarithmic, I mean decibels obviously the obvious one. So that's what the signal looks like when it's down converted. It's the same 2 spikes. Yeah, they have a little extra noise on the side, but it's the same 2 spikes. But instead of the center being at 1080, it's at 455, and I still have my 1Ks on the outside. Everybody with me? All right, so then what do I do with it? Well, these are offset, and what I really want is a signal that looks like VF voltage of minus plus, or plus minus, whatever you want. Subtract the 2, right? So what I've done in this particular board is I made another behavior voltage source, and I said, hey, the voltage of this behavior voltage source is plus minus the minus for IF. And I'll throw that in my filter. This is the thing I need to fix and make a better version of a differential to a single-ended converter with op amps. If you guys beat me to it, I'll give you worthwhile bonus points. I haven't worked out, but it'll be worthwhile. And if you're not the first one, you still get it.
Is that supposed to be the differential, the amplifier stage then?
Yeah, so the out of your Gilbert cell, remember the Gilbert cell on its own has differential inputs, two differential inputs and one differential output. And we added all those resistors and caps off to the right side of that thing, and it forces the Gilbert cell to have a single-ended input, but it doesn't change the output from being differential. So it's still a differential output.
Yeah.
Now, you have two options. You can say, well, how much voltage swing do I have here? A volt and a half, something like that. Could I feed that into this filter and have enough to come back out with just one of them? Sure. You're throwing half of your power away, but yes, you could totally do that. You don't have to do this step at all. Hint, 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 you don't have to. A better design would be take all the power you've got and actually subtract the two, kind of like our math channel was doing. You notice your math channel and your IF channels when you built your double cell, they looked exactly the same, it's just your math channel was bigger because it's the difference of the two. So if I convert this, and let's add a trace, and it's going to be IF plus minus IF minus. Oops. IF minus, close parentheses. Okay. It obviously centers back at 0, which is nice. But look how the top side of this is a little flatter than the bottom side. And look at the top, the thickness of this, and this is much bigger. That's a nicer signal to play with. So if you don't want to double them up like this function's doing, you don't have to, but you'll have a little more amplification to do later. If you take this step, you'll have an easier time later on.
I think I'm still confused. In reality, in our circuit.
Yeah.
Can you just pick one of the
You
outputs? Or-
can, but your signal's going to be weaker.
Right, so if we wanted to do what you're doing with that voltage source there, would you just feed both of the outputs into another? How do you convert it to a single? And
Generally
that filter?
speaking, you do, like what I had in there was an op amp,
Yeah,
and you set the positive, negative, and IF minus, bam, and you set that to the same value just for unity gain, and then you do this IF plus. This is what I had in there,
okay,
and then all these were just the same value, 10K.
okay,
It kind of works. It doesn't work great. That's why I removed it.
okay.
It actually caused more problems, but not because you shouldn't try to take a differential to single-ended conversion, but because this isn't entirely right. So my challenge to you for significant bonus points is to find a better thing of this that works and give me a SPICE file that proves it. I want to see an IF, just send it to me in this circuit and send it to me with the things connected. And if your output looks like this, because this is just literally subtracting the two, if your output looks like this, then great. So anyway, for the time being, this is my input. So my IF looks like this. If I plot IF on here, you'll notice it looks exactly the same because this is literally the same plot. It's the same program doing the same tool. So I'm going to double click on this just so I have the one. That is that one sum or difference?
That's the difference.
Why is it a difference?
It's right there.
We subtracted it.
We subtracted, but that doesn't make it the difference. It's not the difference frequency. This is still both.
Difference of the other hand.
This is a single-ended version of my IF plus and minus. This IF plus and minus isn't referring to sum and difference. It's just referring to positive and negative of phase. And when you subtract them, they're doing this, and I have this bigger wave. And if I took one hand away, this one's still running, it's still doing the same thing, but if I subtract them, this is a much bigger wave. Same deal here. So this filter, which is, I'm going to give it to you, I have to order some. They went out of stock. I have a handful of the older versions, and there's going to be some newer 3-pin versions that I'll give you. This is a 5th order bandpass filter, and everybody but Sam has seen this before. If I open the schematic for this, this should look sort of familiar because I gave it to you last term. And this is just BOIC table coefficients for a 5th order system. And I just looked at the data sheet and said, hey, there's an insertion loss of 3.2 decibels, so change that to 3.2, calculate these values. I don't have to build them because this isn't representative of anything you have to build. This is a part you're going to have to include, and this makes a filter that does exactly what we want. I don't know why I left the measure statements in here because I'm not going to ever hit Control L on this to find out what they are. But when you make an input and an output like this, you can wrap that up into a symbol that just looks like a symbol and has in, out, and that's where those names came from. And now I have that filter as just one little 2-pin part in my circuit. And so if I look at IFF out of this, I get that signal. Now let's look at the FFT of these guys.
Looks pretty
Because
cool.
this is stark.
It looks ugly.
So remember, IF is sum and difference in all the mess. IFF is everything after the filter. So here's 455. And I'm going to remove IFF. I'm going to add it again so it goes on top. How much lower everything except the passband is. So much lower. So much lower. Like all of this stuff just got punted. So here was difference, way over here is sum, right? And the sum frequency just got destroyed by the filter, which is what we wanted. That's what we want to happen. And if I zoom in on this, I still see the same center frequency with my 1 kilohertz, and then it echoes around because life is life, and there's no such thing as perfect through the mixer. What do you think? Are these harmonics off of my data signal? Yeah, they are.
450.
That's why they echo up and down and go down in amplitude. So I said I want a 1 kilohertz tone, but after I processed it all, it got distorted. That 1 kilohertz tone also got distorted, and so it has a 2nd order harmonic, a 3rd order harmonic off of that. It also has, there's the fundamental, a 2nd order harmonic, the 3rd's kind of buried in this lump there. It echoes both ways. It has 1 kilohertz on both sides. So now we get to AM demodulation. I'm going to close some of these panes so we can see this stuff really nicely. I'm going to leave VRF
Ugly.
up here.
Don't sleep. Don't sleep.
But my demodulator, if I click on demod, this is going to put the plot of, this is the signal we've recovered. And it's almost kind of a sine wave, right? It's got a lot of ringing. You see it's kind of, the yellow line's kind of fat there because if I zoom in on it, it's like a voltage rectifier and it has a little bit of ripple on it. So all I did from there is just add it to the dumbest, biggest 3rd order audio filter in the world with a cutoff of 20 kilohertz. And now the green line there is much thinner, and I feed that to my audio in, bleed off to DC, and that's my signal. And if I plug in this, now look at the amplitude of this. It's about 240 millivolts of amplitude. That's a lot higher. It's almost double, a little over double what your amplitudes were last term. So turn your gains down if your amplifier still works. But if I process this all the way through my output, that's not perfect, right? It's okay, but it's not perfect. We're talking about AM radio, folks. You don't have to be perfect. If you hear a tone, you get an A. I'm not shitting you. If you can see your tone on the scope, you get an A on the project. That's all you need.
Vincent.
Does not mean take a 500 ohm or 500 hertz signal and connect it to your output and then probe that, right? Don't bullshit me. This is a lot of signal processing in this block down here. So we're gonna have to go differential to single-ended, put it through a big beefy filter. Whatever lives out of that filter gets demodulated, filtered again, into this audio amplifier, which we all know from last term distorts the shit out of our signal. So if you get all the way to the end and you have a signal that you can hear, and it sounds like the signal you're supposed to be hearing, done. A. Yeah.
I know you said in last class that if we don't have our amplifier from last term, you were going to give us some other.
LM358.
Okay.
Look it up. They have it in the EPL. Read the data sheet, how to connect it. It's easy.
Okay. But
It won't sound great compared to like Parvine's or Sam's, because they built like A+ audio amplifiers.
Mhm.
But it'll be okay. We'll
But,
hear it.
but we should try to use the one from last, or amplifier from last term.
My goal for this class as a, so I'm not super academic-y, like I'm not Rano, right? I'm more of the Dr. Campbell. And I never thought I was gonna stay in school and like write papers and get published, and I'm like, no, I wanna know how to do my job better. So that's what I'm good at. So I want you to, the idea of these projects was every student is gonna walk out with an audio amplifier and a receiver that theoretically can be connected together, and if they all work and stayed that way, which not all of them are gonna, but the idea was you take this into an interview and you're talking about how much you love analog electronics, and here's a superhead radio I built, and here's the mixer, and then I built this LO, and it's got a total harmonic distortion of this, which isn't great, but I only had 12 weeks to build it. And you can talk about all the steps as it goes through, and I just did AM because we didn't have time to do any other kind of demodulation, so we did AM, but it does all this stuff, and I got this IFF filter, and then we built this complementary symmetry amplifier, and it shows, even if it's bullshit, it shows that you seem like you have an interest in the topic. Let me tell you, it's okay to say that it's bullshit. Even when I worked at Intel, which was the coolest, like other than Maddie, none of you will have a job ever as cool as that was, in my opinion. Like, it was too cool. Even then, sometimes I was bored of shit. And I wasn't into what we were doing. That's okay. You're not supposed to be like, oh my god, I just live and breathe for this. Right? We work to just afford our lives. But if you can sort of, not manufacture, but if you can show a passion for this stuff, and it's just sort of like I think this is kind of cool and I had a lot of fun building it, that's enough. You don't have to be like, I just live my life for total harmonic distortion, let me explain the math. Nobody, yes, they like that to some degree, but like, it might think you're a little weird. But if you can show off that you like this stuff, it's a good thing. If you can describe a complicated circuit like this, if you can step them through everything, every dotted block, like, no one needs to know what the node voltage between these two bases is. We don't care, right? But if you know what the input and the output of this block is, and you can explain that it's a Gilbert cell and how that differs from a diode ring mixer, what's the easiest thing to say about that, by the way? What's one have, the other doesn't? Sure, if you want to be a smart ass. Huh? Gain. Gilbert cell has gain. Diode ring mixer doesn't. Diode ring mixers are cleaner, which should make a lot of sense, because anytime you have gain, you get more noise. Every time. So we used the Gilbert cell because our instructor wanted to use Gilbert cells because he uses diode ring mixers in another class, which I will next term. And here's my inputs, and he built this crazy 7th order filter, but I didn't need that, so I left it off. Tell me why you didn't need this filter. And so my total harmonic distortion was this. I'm not going to get any better than that with a filter. Or I didn't need it to be any better than that, and it works just fine. Cool. You've made a case for why you didn't need to spend some money on some parts and some time to implement them, and you've explained it in a way that makes sense with facts. That's the goal. I wanted you to have interview bait and bring something in to show off. That's why I'm nitpicking how clean your circuits are, and I don't want you to Facebook solder like Brad did last term, where it looks all stupid. Because I don't want to be like, who's your instructor? Who taught you to solder? Good. I hope you do. I hope they add me on LinkedIn.
He saw it once.
So that's what all of this is for. I don't know if it probably is a huge answer to your question, but that's the goal. So if your audio amplifier from last term died and you just have it connected to a 358, cool. You can talk about the amplifier you built and it died during testing, and you can still talk about it. But I just put a 358 on it. Cool. Yeah.
So, are you allowed to, so based on what you said, you're allowed to kind of try different, combinations for the other in a way that you might be
Yes.
right?
Yes. This circuit, as it's drawn, it does work. It's real messy. When you actually build it, it's a little messier than Spice comes out to be. Which is why I amplified it with some filtering and then filtered it again.
Like harmonics wise, you mean it's
It's just rough.
okay.
and you want that to be stable, right? Because remember, this has got to be something, I'm going to tune this, also keep in mind, I have a pot here, I have pot A and pot B, and that's set down here, but just like from last term, I kept the same one, where I have this pot, and that's our pot A. Make sure that when you're doing this kind of stuff in Spice, you're not sharing variables, right? You don't want to double define stuff, and you don't want to set both pots to the same value. Obviously, that would probably not be what you need. So I have pot A and pot B. This does work. It's not that it doesn't work. There might be better options. If you want to just carbon copy this, I know what you're going to run into, and it'll work. It'll be okay. If you build the other one that I drew on the board with the two PNPs, that also works. It's a little messier, but it seems like everybody who's built that in previous years had an easier time getting it tuned all the way across the band, and the noise didn't present that much of a problem, even though it has a lot of phase noise.
That's the
But
thing.
do you want to find a
make it
different
less.
solution, as long as it's not an IC that's specifically built
You
to be an oscillator? So I don't want to see you using a 555 timer for a VCO, because that's isn't there anything. Everybody can connect a 555 timer.
Did they have their output, the one who used the? Did they have?
Which one is
It's probably, I probably can't say, and not because I couldn't tell, but there's so many other factors that go into play than just the difference in LO. It's not like their circuits were identical and that, everything else worked beautifully. So it's hard to make that assumption that one LO makes everything better. The one that worked better might have had the worst LO and the best everything else, for all I know, right? You can't. It's hard to evaluate when there's so many moving parts. But they seem to have less frustration on the LO step if you use the double PNP forward positive feedback. If you want to build the coal pits, and I think you were building a coal pits.
Yeah, I actually have a question about
Yeah.
that. So I think the trickiest part about it is trying to get the capacitance range correct for
Yep.
what you want your frequency to tune to.
Yep.
I mean, is it acceptable to just have one tuning capacitor
Sure.
so that you can just?
Keep in mind, you want to keep any spurious AC out of the DC net, and you want to keep that's kind of the game. And this one even has that problem. This is the output. It doesn't really look like it because I don't have it labeled. But this underbar here, from C21 all the way over here, in here, this is the output. But if you notice, this is 6.8 nanofarads, and AC is going to pass through that. It's going to pass through that, and I'm going to get AC there. And if I have AC here, it's going to wobble. So how do you get you don't have to use varactors. I just think that I've only taught this class 3 guys, including this time. I think these make an interesting conversation point to learn about varactors, and the fact there's voltage tunable capacitors that aren't actually capacitors and diodes. And let's talk about those and use them in a thing, even if maybe that's not the best option, but the fact that the NTE618 was made for tuning AM radios tells me that that probably is a pretty good option to use.
Yeah.
Speaking of that diode, who does not have any? Is everybody? I brought my stash from home, and then I am out. The EPL is going to get parking pass. The EPL, if you don't have it, write this down. MV1403. It's not, so the NTE 618, depending what reverse bias voltage you give it, is like 42 to 100 to 420 puff. And this one's about half that, almost exactly half that. And I think it tops out at 210. So what's that mean? Double them up. Put them two in parallel. Hey, you get the same value. But these are more available, and the EPL should be getting them, or you can get them off the DigiKey. You might find packages. Has anybody heard of a 323 package? It's super common. You might have seen it, you just didn't know it was called that. It's a part that looks like this. Right? It's got pins. Sometimes they're, if you're looking at it from the side, it's got, pins that look like this, and they kind of float off to the side. Oftentimes, you can get this guy in a package that looks like this, and they have a shared cathode, like that. Hey, that's already in your circuit, right? Shared cathode, Two anodes, cool. So you can get this part in this package. These obviously won't push down into the holes on your board, but you can get creative. You can dead bug it. You can do a whole bunch of other stuff. I have, this is my last of my NTEs, 2, 3, 4, 5, 6, 7, 8, 9 of them. $4.50, that's how much I paid for them. Who needs them? My Venmo's Nick Redfield.
What is it?
Nick Dash Redfield. That's all I've got. After that, you gotta use these. Nobody can get 618s anymore, apparently.
Why?
I don't know if they just aren't making them right now and we're just at a lapse. When I bought those, there was a ton of them, so I just bought like a handful. And then I
Like a
used a
Colombian
bunch.
coffee.
How many of
But
those do you
this
need?
is 9.
Like a
How many
Colombian
of those do you
coffee.
need to get the?
Colombian coffee is out
You
of the
could
stock.
do it theoretically with 1. But everybody should probably get 2.
What did you say you're,
Should be Nick Dash Redfield.
thank you, sir.
7 left. How many you want?
2.
Where the hell is my bank?
How many you want?
You don't
Who
want
doesn't have them?
This feels like
Yeah, if you've already got
this
them,
feels
I
like
don't
one of
wanna.
those auctions. Dude.
You wanna see? Can I see? Can
No,
I
you
see?
cannot.
Just see it. I wanna see it. I don't want it.
This feels like an auction right now.
1 left.
Nick, can I see it?
I mean, it's tiny. It's
Oh,
Yeah, yeah. I have 15 bucks.
do you want it? What?
You're out already?
I have 1 left unless Sam's taking that one.
Who won?
You want it?
Dash, Redfield.
You have a sale of people?
Huh?
Sale of people?
You can sell it
I don't have
$5.
Zelle, but PayPal is.
Since it's out of the stock, we can sell it expensive. Why you didn't get
I'm
it?
gonna assume that's him. I mean, it looks very. Yeah.
How much for 50?
Huh? 450. Yeah.
That just for verification, that's you, right? It's just the way it looks.
That's an engagement photo.
Hey,
450.
So why you didn't get it?
plus minus.
You bought
Doesn't matter. You're just tracking them. Yep.
EPL doesn't have it.
And all we really care about. Remember, this is our input signal, and
MD14
this wave here is the data we're trying to recover. And if it's just tone, we don't care where the phase starts.
Why is your difference here?
How many he had?
It was just noisy.
7?
Yeah, it was way too much noise. It's not that it didn't work.
EPL.
It was way too noisy, so then by the time it came
I
out of the
got
filter,
two.
there was a huge delay out of it, and then
Other people
the
need
amplitude
it.
that came out, this orange line at the end of the line here, was so small that when you amplified it, it was just even more noisy, because you're amplifying the noise.
Evil thing that
Theoretically, all filters ever are Chevy Chef. There's no, Butterworth is actually a,
What is that?
What's up?
yeah, okay, fine.
Tell me how you did for that.
I did, yes, I did everything, I
It
did
was
everything,
terrible.
I glued everything together, impedance
It was
and
terrible.
filters for, we using both.
Michael left really
Some
soon.
I'll try, but if you.
Did you
use
notice?
Filters, it's supposed to help with bass.
Sure. We don't actually care about bass.
What is it? What is it?
Phase distortion is one thing, but we don't care about phase.
As you feel it.
We don't care about the delay. By the time you get it all the way, by the way you hear it, it's already, there's already a little bit of delay. As long as the
You should
song
buy
stays
it last
playing,
time when I
don't care
told
if it
you.
started 14 milliseconds late, you'll never know.
Taylor, you should buy it last
It's
time I
like
told
9:50
you.
a song. Or for AM sports.
I know, it's terrible, Gummy.
The last 4 digits of your phone number.
9686.
Let me know if you received that. Okay?
Half you guys have my phone number already, I think, so. I put it on my email responses, I think it just sits there.
Why we have to have it? Why? Why?
What those?
Where's- More. In here.
So I am out of diodes, the EPL is out of diodes, Varactor diodes specifically. And if you need something else, substitute that guy. If you burn those out, sorry, that's all I got. See if Sam will get on a bulk order and do, and I think you were gonna buy.
I got it.
You got it, did you bring it?
I know.
You didn't bring
I
it?
just didn't
How
bring
big is
it.
it? Is it huge or is it just like a little guy?
No, it takes long to get the home.
Oh, you don't have it yet?
Yeah.
Oh. How long is it supposed to be here? You don't wanna wait too long.
Oh, really?
Well, but yeah, you gotta turn something in.
How many of those I need?
You gotta have this thing built, you can't have it, it can't show up in April.
I have to convince him to buy it. We both.
I'm not getting that, dude. I'm not doing that. That's one component. That's $34.
And so,
How many you need?
how my local oscillator.
5?
Son, think about it for a
If
second.
I change,
One component,
the
one
configuration.
component, $34.
Am I gonna be able to, do I need to change? the
Too many.
filter?
Two of them will be needed.
Like, I'm gonna amplify it, probably.
So my filter is
So how
based
many of
on-
I need
this
of
is a
that? If it
$600
works,
plus
I want to
the
buy
output,
it.
Right? So
I think you need two.
if this has roughly a
Two?
$600 output and this has roughly twice that or 3 times that, I think it has, give or take. So I said that,
bought that.
that's what I set these coefficients for, because you notice
Really?
these are all unique values. They don't repeat on the second half. So there's an impedance transformation that's happening. These are also rounded values. This was like 92 and this was 95. You can't get 92 and 95 microhenries. So, well, it's gotta be 100. And it's gonna be a little ripply there and that's why. Yeah.
Are these the ones that you're talking about? The MD1403s?
Yes.
Let me see. Let me see.
The nice thing about the MB1403s is there's a very clear cathode line on it. Like very, very clear. It's a tube with a stripe on it and legs that come out, right? So it's real obvious. Those 618s, if you look at the face of it, and the data sheet is on the front, but the image of it's on the back, it hasn't rubbed off too much. But it has a 618 on it.
If I understand how everything works, I can be
A.
but
Okay. And a cathode.
I don't understand. I don't know how everything is works, honestly. I just look at this schematic and build it.
So that's what you were saying, because you said.
The
100
8 side is the cathode.
Yeah, so right here, this one says that 120 to 250 picofarads, that's what you're saying, put in.
Just put two of them. Yeah, put them in parallel. Same thing.
Don't burn them.
Which design uses?
If you burn,
What's what?
it's gonna burn.
I see
You're
it
gonna
on
go
the-
buy it too? $34.
So the 618 can handle up
I'm
to
serious.
18 volts. Let's actually talk about that. The 618 can handle up to 18 volts. This whole presentation runs on 9 volts. That's what the SPICE model runs on. You can run whatever you want, up to probably 18 volts. Probably shouldn't go any higher than that. In fact, getting to 18 might be a bit much. Keep in mind also, if you're using if you're using this step and you've got an op amp, look, I've got VEE. What's that mean? Negative voltage. I got a negative voltage rail I have to account for now, so it's another power supply. So I've got 9 volts. I did 2 9 volts just like we did last term.
Would it be possible to try all this?
Depends on if you
What
use
is
what parts you use. Do I need that amplifier and filter?
What is that?
If I can get away with that without using it, I don't need it anymore.
What's the DC offset going into that?
Oh, that's a good
I don't know. You want to see how you find out though? Here's the thing in SPICE that you
Why
can
you
do.
have a lot of that?
So Brad's question was, what's the DC offset of the signal going in here? You right click
Oh,
and say place off point data label. It just tells you, and then that's the DC value, and you can shorten that.
I don't have it.
And when you run it, it'll tell you the voltage. As many times as you want to click those things around, it'll tell you the DC voltage at all your nodes.
Crazy question, do you think it'd be possible to power this
That's
whole
why I came late,
project
because
with a
he just
single
wanted to
full
go
power supply?
Yes, but you're going to have trade-offs. You probably won't be using very many op-amp solutions, for example.
Well, you could ground that.
You could center, you could play with stuff like that. You don't always have to. In this one, I didn't. Alright. So, but look at what I've done here. And I was just talking to Tim about this earlier.
Because I see you're using 6
So I'm running this off of a 6-volt supply, right? And I'm driving it here. Now I just called it 7806. Why did I call it that?
regulator.
Like the voltage regulator. 7800 series, 6-volt output. That's what this means. 78, the output 6 volts. And the pin out of those is super dumb and easy.
In, out.
In, ground, out. And they have a big pad on the back, and this is also connected to ground. In, ground, out. And then it's good practice to always
Capacity.
bypass cap and bypass your output. And the other rule of thumb, which rules of thumb are great until you have better data. In this case, we don't have better data. The better rule of thumb is your input capacitance should be 10 times higher than your output capacitance. A lot of load switches, this is in the data sheet. Does it have to be exactly 10? No, but that's the rule of thumb. So if you use a 7806, that means this voltage is going to be 6 volts, and this voltage is going to be 8 or higher volts, probably 8.3.
They typically can handle up to 24, like those.
But what's the trade-off if you put 24 on it?
Yeah.
Why might it not be hot? How much current? So this is 6 volts. How much current is running down this path? This is 100K plus whatever these are, so this is like 150K. What's 6 volts? What's the current over that? Real small. What's the current through this? This is probably your bigger issue. So what's the current? This is your power draw. So as long as you aren't transforming, how much current are you dropping? And this is, let's say this is 24 volts. 24 volts, you're gonna drop 18 volts times however much current is wattage. That wattage will present itself as heat in a very small device. So oftentimes there's a heat sink for these if you need it. You probably don't need to step from, you probably don't need to go all the way to 24.
No, I was just saying that they can.
But theoretically,
up to that.
I like these because these have very clean outputs. Very, very, very clean. And what's the last thing I want? I want my voltage, and I'm having a voltage divider that comes through here. I want this voltage to be stable. I don't want it coming from a switcher. So I don't draw a lot of current, and our voltage regulator is a great option to use for setting this DC voltage in this very precise way.
So perhaps would it be a good idea to use a single 12-volt system and then just use a bunch of leader regulators?
Sure, you can go 7809 to 7808 to 7, and then you can't go to 8 because you can't go from 9 to 8. You don't have the dropout, right? But you could go from 9 to 6, and then you could split the difference.
Okay.
They make, I think there's a 78317T, and this is adjustable. So you can go all the way down to 3.3 output. I think you can go all the way up to something else. 17, I want to say.
So is it kind of like a buck converter type of?
Well, you have to put, there's more resistors and shit you have to put in, but not that many more. It's like three more resistors, and then you can make it variable.
Oh, so it's bias dependent?
Yes, it's not a buck, because it's still linear regulation, it's just dumping. But they make a variable version.
That's cool.
Yeah. These do come in the TO220 package, like this, and they also come in the same package that a 3904 comes in. Why would you use one or the other?
Depending on how much heat you're gonna be generating?
Yeah. Yeah, this is a lot easier to blow up than that. So, if you're barely using any power, use one of those. It's small, it's tiny. If you're gonna be cooking some meat, then put that on and put a heat sink on it.
This
Blow a
is so
fan on
cool.
it, and yeah. For this, you probably can't find. These are hard to find, honestly. So you're probably using all these anyway. When you buy the kits online, usually it's this package anyway, because they're more general purpose. But I really like using that. So
Does the EPL have those?
I don't know, but Amazon does.
Okay.
Amazon has them. You can get them next day.
Okay.
They do have them, but Amazon is a cheaper option. If you're being.
So let's talk about how to tune this thing. And I keep going to Ivan because your last name's Ivanov. Tim and I were talking about this in the EPL. What are R28 and R29?
R20.
Windowing resistors?
Yeah, you already know, but what's that mean?
So you don't blow it out.
Nope. Has nothing to do with safety. Has nothing to do with,
You're reducing your mid and your max
yeah.
Equal in the
ranges.
range of voltage.
So when
So
you're
I don't know how much
setting
voltage
your-
I need to get my whole range, like,
You're just tweaking with the delta.
so the frequency, so my frequency of oscillation, let's call it FLO, very roughly is going to be 1 over
Oh, shit.
2 pi
Would you get that's
root, let's call it root LCT, right? CT is gonna be this cap plus this cap. This is a bleed off resistor plus this cap, and I have this inductor in here, and then I have this cap. Now these are all in series with each other, roughly. So, except for this guy, because this is where it comes in and feeds. So the way this is going to work out is these are 42 to 420 picofarads, and that's a microfarad. Several orders of magnitude bigger In fact, this nanofarad is also a couple order of magnitudes bigger. So they become sort of invisible. It's kind of like if I have a resistor, 100K is in series with 10 ohms. What's that impedance look like? Pretty friggin' close to 10 ohms, right? It's so many orders of magnitude bigger, this might as well not be here. What we get out of it, though, is that this is a DC block, which is what we want, and this is a DC block, which is what we want. So they sort of become invisible. So all of our oscillation is going to be based off of my L, which is 100 mic, and these two guys, which we're adding together. And that's we're going to get to CT. And that's a very general, rough value. So my CT is roughly 84 to 840 puff, and my L is 100 microhenries. Give or take, you're going to be winding this on a toroid yourself. So if you get 120 mic, not the end of the world. If you get an 84, it's close enough. You can't do half turns, you know what I mean? Like it's gonna be some number around this point, in this ballpark. So you need to tune this value. You have 2 orders of magnitude to, or a whole order of magnitude to play with, and you need to tune this value. And when I tune plus 6 volts, and I have a pot, and it's 100K, because I want a really big value, to ground, if I just pull this out of the bag, remember that the impedance seen from here to here is 50K, and the impedance seen from here to here is 50K, right? That's just out of the bag, the knob comes roughly in the middle. So if I have 6 volts here, I have 3 volts here. Duh, right? How much voltage swing do I need on those varactors to tune my my capacitor pair, or whatever capacitors you have? You have 1, you have 2, however many you have. How much voltage does it actually need? And if you feed this with something like 18 volts or 9 volts or something big, you're just increasing the swing that this is coming on. So if we say that to tune from 995 kilohertz to 2155 kilohertz, which is the AM band, I'm going to make up some numbers just for the sake of argument. If we say that this we need plus 4.2 volts, and at this point we need 2.1 volts. Again, I'm just making up numbers. I've got a 6 volt swing, so if I tune this knob all the way to the top here, I've got 6 volts on that, right? I don't need 6 volts. What frequency do I get when I'm at 6 volts? Let's make up some numbers. So at plus 6 volts, maybe I'm at like 2950 kilohertz. Maybe I'm at 3950 kilohertz, right? And when this is all the way down at the bottom, and it's roughly at ground, let's say it's roughly 0 volts, this might be something like 700 kilohertz. I don't need to tune this far. I only need to tune this far. So what you might find is that if you put, I'm going to erase these because you understand how pots work. If you put some resistors here additionally, and you'll kind of experiment with the value once you kind of get what the voltage is, I'm going to pad these values so that when I'm turning my pot, if I turn my pot all the way to the left, maybe I'm all the way to the left. Maybe I come in just before 995. And if I turn it all the way to the right, all right, thank you, Matthew McConaughey. If I turn this all right, I'm at the end of my line. Now I have very fine control over exactly what frequency I intend to turn to. Now, you could buy the answer, Sam. You could buy yourself a 30-turn pot for 30 bucks. Or you could use a 10-turn pot that you get for 8 bucks, and you get like a whole kit of them, and then you just add some padding resistors, which costs you a nickel. If that. And you can get your whole range of motion that way. I still recommend using 10-turn pots and not the 270-degree ones. Everybody remembers what I mean about the 270-degree? I'm gonna draw it just in case someone's not telling me and you're lying to me. If you buy the pot that looks like this, and it's got like 3 pins on it like this all the time, and this is like blue plastic, and there's just like a screwdriver hole, typically they only have, like if this is all the way to the left, you can rotate it 270 degrees. You can only rotate it that far. And it's really hard to tune exactly to 1535 kilohertz if you can only turn it 270 degrees. Like every time you touch it with the screwdriver, you're gonna be shifting it and you're gonna be chasing your zero back and forth. If you use a 10-turn pot, you get a lot more resolution per turn. It's not so fiddly mechanically. Electrically, it's the identical, yes, but mechanically, it'll drive yourself crazy. And you should still have 10-turn pots from last term. If you don't, somebody else here does. Most of you bought the big kit, so. Questions? Does everybody follow the circuit? I'll post this. You guys already have most of this, and you can still use it. The only thing I changed is I removed this guy down here, and I changed the signal generator inputs so that you can play with them easier.
You also said that you were going to provide the if filter, right? LTW.
I mean, I have the filters at home. I need to buy more of them, but those have not been discontinued. I just need to actually buy them. And those I'm buying for you, they're my gift. That was buy the wrong ones. And I bought everybody else's last couple of years, so I keep the issue going.
Which is classes and churches.
Yeah.
Muchas
Are
gracias.
you talking about the 455?
Yes. Yeah, I forget. And I will publish this. I will publish my
Nothing
symbols.
inside.
So here's one thing you'll need to know.
No.
This is a real important one if you're using my
Okay.
simulation. I'll give you the symbol model for my 5532, which I've made, and it's pretty. Look at my plus and minus. I drew it myself. Right? If you right-click on this, here's the model. Here's the symbol for it. If I can open that symbol, that's in my hard drive. I can give you the symbol.
Yes.
Easy.
Please. I
But
couldn't
now-
run it.
I need to get into, oh, how was it? You can't just use it that way. Pin table? No. One sec. It just says today, so give me a sec. Oh, I wrote it. No. Oh, no, where is it? Edit attributes. There we go. Edit attributes. Right-click, edit attributes. I can give you the mod file. Here's the txt description of the 5532, which you remember, that's the actual model. When I give you this symbol, this .asy means symbol, a symbol, sy. You'll have to change your model file. It will not be in C users Redfield documents. It'll be wherever you put it. Unless you guys use my username on your home computers, it won't be there. But the symbol thinks it's gonna look for that. So you need to put the text file wherever you want, change this line in the model file to that location or it won't simulate.
Okay.
Or you could just build your own model, I don't care. Like you can take the text file, right click on the blue text like you did before, and build your own model, but it'll be ugly, it won't be as pretty as mine. You pick.
And hit OK.
But yeah, that's what you need to change.
Yes, that's I
And you
noticed.
just
I
get that by
couldn't
right
run it.
clicking,
I couldn't run it because I don't have that.
attributes,
I pasted the
no,
text file. Edit attributes.
yes. Right click,
Okay.
edit attributes, model file. That's for the recording. That Sam will post. I don't know, post it. You don't post them to the Discord channel because nobody uses Discord anymore.
Yeah.
But someone did. Someone did that today on Discord. It was class tonight. But anyway,
Who was it?
so that's how you use everything I've given you in Spice.
I want everyone
this
to use
model,
except that
I didn't
one.
use a Spice model for. So if I just give you the symbol, if I just give you the schematic and the symbol, all of that data, that is the whole model, and it's just built into that. There's not like a text file that goes along with it. So that'll just work. And this is just really fancy shit that we did last term. This shouldn't be news, it's just busy. Anybody have questions about the filter? Okay, I think we beat him to death last term. But this is the whole thing. Yeah, maybe you don't need this block. Maybe you don't need this block. Maybe you do. Maybe you need filters elsewhere. You're definitely going to need them where you don't want to put them, and it's going to be frustrating. Your LO is going to be the hardest thing you do this term, but that doesn't mean you're done when you're done doing your LO. You still have to connect it all together. So one thing the SPICE model is really useful for, especially this big one, is I can look at my RF and say, okay, here's what my RF looks like going in. And if I click down here, and as soon as I click on it, oh, wow, it's offset now. What happened? You're going to look at this on the scope, and you're going to probe this point, and not this point, and you're like, what the hell happened? What happened? Why is it DC offset?
Because you have to bias the network.
Because we biased it. We did it. That's what all of this crap is,
Yeah.
right? So knowing where you're probing around, you can sort of get a feel for, hey, if I probe this side, I should see it DC offset of nothing for my signal generator. And I see the same thing over here on LO. If I look at my LO on that side, and over here it's DC offset because I have this whole biasing network from in here. Same concept. But you should be able to probe around the inputs, the outputs, and see how it all works. The mixer is pretty self-explanatory. But you'll poke around, and if I can look at what my my outputs look like, and everything has to be tuned. If you're playing with this file in particular, you'll have to cheat, and I'll allow you guys to cheat on your projects as well. So it's really hard. There's no knob to turn on the SPICE model. I'm typing in a value, 39K, 41K, 56.9723K, right? I'm buying nitpicky values, but I'm not actually turning a knob and watching the output. I have to change the value, run the simulation, and wait like 30 seconds. It's tedious. So one thing I like to do is just set it to some value. Who cares? I picked 39. And I said, what is the frequency that is closest to? And it's 1555 or something like that. So I said, okay, I'm just going to set my carrier frequency to be 1100 then. And if it was 1556, then I would set my carrier frequency to be 1101K, right? That way all of my stuff down the line lines up. I don't care that 1101 isn't necessarily an AM station, and I don't care for this project, although you should shoot for that. You should try to find it to land on an AM station channel number. But if it doesn't work, then it doesn't work, it's fine. If you get your signal out at the end, that's all I care about.
Okay.
I'm seeing confused faces.
Oh yeah.
What are you confused about? What I
I
just
don't
said?
know because everyone is confused.
Okay, in SPICE, I built, and you're gonna have built as well.
I just not only me.
In SPICE, you're gonna have this amplifier, local oscillator. You feed it some power and some signal comes out. And let's say initially you can't get it to tune exactly where you want, or you can't get it to be still. And you can get it to be still to, I don't know, 1001 kilohertz.
1,000.
That's a bad example. You can get it to be still to 1500 kilohertz. That's where it's really stable, and you want to test something else in your circuit. You'll get to the LO later. You want to test if this is working with your circuit. And so here's your LO. Your RF, remember, is the signal generator. You get to pick what frequency this comes out at. You get to pick whatever you want. That's not realistic, right? Normally, our RF station is a broadcast channel, and we can't change it. But we're in the lab, and we're faking our RF signal with a signal generator. So if your signal won't be still at any other frequency than 1500, yeah, you have some work to do in your LO, but if you want to check to see if everything else is working, you're going to set your signal generator to what? I would recommend 1005 kilohertz. Why?
By frequency, subtract
subtracted, yeah, LO minus IF is gonna be RF, high side injected. So now I'm gonna broadcast, air quotes broadcast, and I'm gonna AM modulate, let's say, I don't know, 500 hertz tone, because it sounds nice in the lab. It won't matter early on because you won't be playing anything. But you're gonna AM modulate some tone onto 1005 kilohertz, and by the time it runs through your mixer, it's gonna run, your RF's coming in your signal generator, your LO is stable at 1500K maybe, and your IF is gonna come out at 455, because that's what the subtraction is. And you should see, at 455, you should see that come in. Mixer, LO, IF. Come out of your IF filter. You should see your signal here. Even if your LO is only stable there. You'll get a good grade. If it only works at one frequency, you won't get the greatest grade, but it'll be good.
Okay.
It's a B+ level. If you get your oscillator to run at one frequency. If you can span most of the channel, that's A target. Good?
Good. Next class. Next class is lecture or lab?
Wednesday's lab. Let's do it.
Okay.
How many more
Let's-
lecture days do you think we have left?
Not many. Why don't we do,
Lecture.
obviously this Wednesday's lab and all of next week is also lab.
Okay.
Does that sound good? And get some time in?
All of next week's lab?
All next week's lab.
That is good.
So it doesn't mean like fuck off and don't come, and don't get stuff done, because I'm still coming and spending my time to come here. So show up,
Ask a bunch of questions.
ask a bunch of questions. That's why I come here. It's just to watch you guys like yell at me and clean up the circuits. It's to answer questions.
Alright, see you Wednesday.
Yeah.